This video is introducing you to trigonometry, and it's part of the relationships unit. Trigonometry means triangle and measurement, and it's used to calculate missing angles and sides of right-angled triangles. So here we've got a triangle. We're going to mark in the right angle. We're also going to mark in an angle of x degrees. The side that is opposite the right angle is known as the hypotenuse, and that's the long side of a right-angled triangle. The side that's opposite our angle of x degrees is known as the opposite side, and the side that's adjacent to our angle of x degrees that's not the hypotenuse is known as adjacent, because it's the one that's beside our angle of x degrees. So we're going to look at the tangent ratio first. Now our tangent ratio in a right angle triangle is the opposite side divided by the adjacent side. So tan x equals opposite over adjacent. So we're going to use the tan ratio to calculate a missing side. Now, in our triangle, we know that the side opposite the right angle is known as the hypotenuse. And we know that the side opposite our 60-degree angle is known as the opposite. And we know that the 12-meter side is known as our adjacent side. And if we're using the tan ratio, we know that tan x equals opposite over adjacent. So we're going to substitute in the values that we know. We know our angle x, so we can say that tan 60 equals. The missing side we're trying to find is our opposite side, and we're going to divide that by 12, which is our adjacent side. Now, we know that if we're solving an equation, we need to get O isolated. And so we need to get rid of that divide by 12 onto the opposite side. So the opposite, or the inverse process of divide by 12 is multiply by 12. So we're going to do 12 times tan 60 equals our opposite side. And if we put that into our calculators, we're going to get 20.8 meters to 1 decimal place. So the first example, we're going to find the height x of this triangle. So we don't have any value on the hypotenuse, which is the side that's opposite our right angle. We have our missing side on the opposite side, which is opposite our 65-degree angle. And we have a value on our adjacent side. So we're going to be using our tan ratio, because we're looking for the opposite side, and we have our angle, and we have our adjacent value. So tan x equals opposite over adjacent. So we're going to substitute our values in. So tan 65 equals opposite, which is x, divided by 8, which is our adjacent side. Divide by 8, we need to do the inverse process to get x isolated. So we need to multiply both sides by 8. So 8 times tan 65 equals x. And that gives us a value for x of 17.2. And our units are meters. And this is to 1 decimal place. Sometimes you won't be given a diagram and you'll have to draw that diagram for yourself. So in this example, an aeroplane is preparing to land at Glasgow Airport. It's over Lennoxtown at present, which is 15 kilometers from the airport, and the angle of descent is 6 degrees. What is the height of the plane? So let's draw ourselves a sketch. So we've got our aeroplane. We've got our 6 degrees marked in. We've got our adjacent side, which is 15 kilometers. And we've got our opposite side, which is the height of the aeroplane. So we're going to use our tan ratio again, because we've got our angle and we're looking for the opposite side, and we've got our adjacent side. So tan of 6 equals h over 15. So h equals 15 times tan of 6. And that gives us a 1.58 kilometer height for our airplane. So the previous examples have given us the angle and asked us to find the missing side, but sometimes we'll be asked to calculate the missing angle. So you can see here that we want to calculate the tan x ratio. So we know which side is the hypotenuse, and therefore we can work out which side is our opposite, which is the 18-meter side, and which side is our adjacent, which is the 12-meter side to our angle of x degrees. So we're looking for the angle this time, and we've got our opposite and adjacent sides. So we know that tan x equals opposite over adjacent. So our tan x ratio is going to be our opposite side, which is 18, over our adjacent side, which is 12. And we can simplify that down to 1.5, or if we want to leave it as a fraction, we could leave it as 3 over 2. So from the previous slide, we know that tan x, our tan ratio, is 1.5. So to calculate the angle, we're going to press the shift button on our calculators, and then the tan button, so that will give us the arctan or the inverse tan button, which is the button that we need for calculating missing angles. Then we're going to enter 1.5, or you can use your fraction button to enter 3 over 2. And then we're going to press equals, and that's going to give us an x value of 56.3 degrees. And you can see there, the way we would write it down for our working out is tan to the -1 in brackets 1.5, because that's what's going to be typed on our calculator screen, and that's going to equal 56.3 degrees to 1 decimal place. So here we've got an example, and we want to calculate the angle the support wire makes with the ground. So we're looking for the angle, we know what the opposite side is, and we know what the adjacent side is, so we're going to be using our tan ratio. So we can say that tan x equals opposite over adjacent, and that equals 11 over 4. And so x equals the arctan of 11 over 4. And we're going to use our fraction button on our calculator to get an exact value, because we don't want to do any unnecessary rounding. And that gives us an x value of 70 degrees. So the angle that the support wire makes with the ground is 70 degrees.